need to look at this is because initially we see that the information given is side-side angle. So it's an ambiguous case. We could have 1, 2, or no triangle. And again, I'll show you what the no triangle example is going to look like. First thing we like to do is I always like to set a visual. So I'm just going to create a random triangle and just label it with the information I have. So I don't have any information for C, angle C, or side length C, right? But I do have enough information for A and B that I can do the law of sines to solve for angle B, right? So that's basically all we're going to simply do is just figure out what angle B should be. So let's go ahead and set up. Now I'm solving for angle B, so therefore I'm going to want the angles to be in the numerator. So I will have sine of 23 degrees all over 2 is equal to sine of B all over 8. Right? And the reason why I like the angles to be in the numerator is because now to solve for sine of B, all I have to do is multiply by 8 on both sides. And I have sine of B equals 8 times the sine of 23 degrees all over 2. But we're not solving for sine of B. We're solving for B, right? So that's going to be sine inverse of that answer. So I go ahead and type in my calculator. And I do 8 times the sine of 23 divided by 2. Now you realize you get 1.56. Oops, write that in there. Of 1.5629. And then, ladies and gentlemen, if I do the sine inverse of that answer, second answer, I get an air domain. OK? So that means no triangle can exist. There is no angle where we can set a triangle. Now, how does that look visually? Well, guys, let's pretend this is drawn to scale. If this is 8, should that be 2? No, 2 would look something like this, right? Yes? Right? So it doesn't matter how long I want to make this or however I want to change this angle, it's never going to create a triangle. Right? So therefore, no triangle would exist.